Good morning to one and all. I'm Soumya from Government Women's College, Kola. The session 4 of the Unit 1 consists of problems. The first problem, calculate the fraction of oxygen molecules within 1% of the most probable velocity at NTP. What is the effect of changing the gas to hydrogen? The second one, the temperature to 500 degree. The fraction of molecules having the speed between v and v plus dv is given by the following expression, and the most probable velocity is given by it is square root of 2 kt by m, and by substituting the equation 2 in equation 1 we get the expression as p of v dv is equal to, it is a function of most probable velocity. And we know that the gas velocity varies within 1% of the most probable velocity. So hence the most probable velocity lies between 0.99 to 1.01. And further, the change in the velocity can be written as 1.01 minus 0.99 times the most probable velocity. Hence, on further simplification, so we get the value of most probable velocity as 0.02 into square root of 2 kt divided by m. And by substituting these values in the already simplified expression, so we get it as 4 divided by root pi exponential minus 1 times 0.02. And further simplification, so we get n of v dv divided by n as 0.016. The problem 2, calculate the probability that the speed of nitrogen molecules lies between 149.5 meter per second and 150.5 meter per second at 7 degrees centigrade. So here the final velocity is 150.5 meter per second and the change in the velocity is 1 meter per second, and now the temperature is converted into Kelvin, so hence it is 280 Kelvin. And we know that the mass of nitrogen is taken as it is the ratio of molecular weight divided by the Avogadro number. So hence it is 28 divided by 6 into 10 to the power of 23. Now we know the value of mass of the nitrogen and the corresponding velocity and change in the temperature and change in the volume and the corresponding temperature. By substituting all these values in the above expression, so we get the probability of a molecule as 7.4 into 10 to the power of minus 4. The third problem, calculate the root mean square velocity and most probable velocity for a gas whose density is 1.4 gram per liter at a pressure of 10 to the power of 6 dyne per centimeter square. Now we know the value of density, it is 1.4 gram per liter. So hence now we need to convert that into SI unit. So hence it is 1.4 in 10 to the power of minus 3. It is gram per centimeter cube. And the pressure is given, it is 10 to the power of 6 dyne per centimeter square. And we need to calculate root mean square velocity and most probable velocity. Already we know the expression for root mean square velocity and as well as most probable velocity. The root mean square velocity in terms of the density, it can be written as square root of 3p divided by rho, where rho is the density of the particle which we have considered. So hence by further simplification, so we get the root mean square velocity as 4.6 into 10 to the power of 4 centimeter per second. Again, we know the most probable velocity, and on further simplification, so we know the most probable velocity and root mean square velocity expressions. So on further simplification, so we get the expression for the most probable velocity as 3.77 into 10 to the power of 2 meter per second. Calculate the RMS speed of a hydrogen molecule at normal temperature and pressure. Given K is equal to 1.38 in 10 to the power of minus 16 erg per Kelvin and Na is equal to 6 into 10 to the power of 23 molecules per mole. And now the values which we know are the value of K and as well as Na. The molecular weight of hydrogen M is equal to 2. So hence we need to calculate mass of the hydrogen molecule, which is molecular weight divided by Na. On substitution, we get 3.3 in 10 to the power of minus 24 grams. Again, the root mean square velocity expression is square root of 3 kT divided by m. On substituting all the known values, we get the value as 1.38 into 10 to the power of 3 meter per